Let me welcome everybody to this exciting workshop on a 5 degrees Celsius Arctic in a 2 degrees Celsius world. My name is Peter Schlosser. I'm one of the organizers here. During the introduction you will hear some short remarks from myself, then Brad Egg from WWF and from Rafe Pomeranz from Arctic 21. And finally, Teresa will make a few comments on logistical issues. We have people coming in remotely via Skype. They are not fully connected yet. I think the technician who will connect them is on his way. So if somebody starts to work on the computer while we are giving the introductory remarks, don't be surprised. That is just making sure that when the real sessions begin, that we have them online. So let me talk just briefly about the history and the context of this workshop. It actually is, in essence, a continuation of the discussions that we had during a workshop on the White Arctic, Blue Arctic that took place about 3 years ago here at Columbia, and that also was instigated by the same suspects. I think Rafe was part of that, Stephanie and others. And at that time, the topic was figuring out what might the future actually hold. Are we moving towards an ice-free blue Arctic, which is actually mainly the ocean, the blue for that, or to which extent will it stay white, or more importantly, can we actually turn, if it turns blue, can we turn it back to a white Arctic? Do we have the means to geoengineer the planet? And these discussions, although originally they were sort of focused around sea ice refuge and things like that, habitat preservation, brought out a very interesting topic that was then the main focus of a little paper that we submitted and that just has been accepted, led by Bob Newton, on actually the emergence of a diverging set of stakeholder interests, because there are more and more people who see in the opening of the Arctic Ocean opportunities, shipping, access to resources, etc., while at the same time there is of course a stakeholder group who doesn't want this thing to open. And if you go to Korea, Singapore, etc., it's fairly openly expressed at this point that they would like to develop the shipping route. And so this stakeholder tension, as I like to call it, I think we will see on a global level, but we see it much more pronounced and much further along in the Arctic right now, because as we all know, the Arctic is actually moving faster on a lot of these environmental change issues than the rest of the globe. So there was then a while of sort of a period of contemplating how to pick that up and take it further. And when these discussions started again between Stephanie, Rafe, Brad, and others, it happened that the Science Ministerial was planned. So it was actually a nice period to pick up that topic again and have actually two lines of inquiry that we can pursue here. One is to look at how far have we come in our understanding of the trajectory towards a blue Arctic, possibly turning back into a white, or can we do that? But at the same time, the opportunity to feed some of this information into a political process that hopefully at some point gets traction, that takes our knowledge into action. And so what one of the major goals of this meeting is to brainstorm about what kind of messages can we relate into that political process, centralized here or focused on the Arctic Science Ministerial that takes place in DC on September 28th. And by which means, what does really resonate? Because just looking around the room, I see so many of you who have been at similar meetings where we said we have to get the message across, you know, and we wrote conference statements, we wrote white papers, we, you know, tried to have the press involved to get to the media. The message, actually, I went back through many of these conference statements. The message has not changed that much in terms of the scientific content of what we are seeing, what we are concerned about, what we want to have addressed. The question is, where is really that bottleneck that, you know, has to be unlocked in order to get to action? And that will be the main focus one main focus of this meeting. Most of this discussion will take place tomorrow. Today we will sort of use to get oriented, to, you know, get some sort of a picture. Some of you know more of it, some of you know less of it, but at the end of the day everybody knows everything about, you know, where are we in terms of transition of the Arctic, where do we believe it's heading, and importantly, how does that fit into what is a real political target now in terms of global temperatures, the COP21 target, 1.5 to 2 degrees. What does that mean for the Arctic? But also, how does that link back, feed back into the global context? And then tomorrow, we will sort of really try to figure out how can we frame some key messages that might resonate and might, you know, give the science ministerial or those who are participating in it some information that they might actually be able to use to move more towards action. The way I like to frame that is to say, you know, how to move from the idea space to the solution, translation, and implementation spaces. You know, where's the valley of death in that? Because we clearly seem to have one at this point. So just briefly to the format, as you have seen in the booklet and the message that was sent out yesterday, this is meant to be structured but still have enough flexibility so that we can enter into new intellectual spaces if we see them opening. We have short presentations to introduce the main topics in different sessions, but there's always quite a bit of room for discussion so that we can exchange how we are seeing these things, especially tomorrow. How, you know, what do we see as ways to really communicate our message and make it stick? And then we will introduce we want to come out with a good draft of a briefing paper, and so we will introduce that by offering to the audience a few points that we will start from, 4 or 5 topics around which such a paper could be structured, and then we will discuss how to actually fill that into something that we all feel comfortable with, that has enough content but also is written in a way that it might resonate. And, you know, several members of several participants here have actually quite a bit of involvement in that political process. Stephanie was, Rafe, to start with Rafe, he has quite a bit of interaction with the political side, OSTP, others. Of course, WWF has that. Stephanie was at the White House yesterday to talk to the organizers of the Science Ministerial about certain things, so she can feed back what she learned there. So we have quite a few people who have actually deep connections into that process, which is, I think, a big advantage for us to frame the message correctly. Just wanted to make one final remark about the support. I mean, we will hear from Rafe and Brad, who were, you know, big supporters, but in addition to the initial group that came up with that, we were able to entrain as co-sponsors the Lamont Climate Center, Future Oceans, the the Arctic Institute of North America. We have the International Arctic Research Center. We have MIOPA, which stands for, now I'm on the block here, for Marine Environmental Observation, Prediction and Responding. So, you know, right on target for our topic. And I hope I didn't forget somebody. They are all listed at the back of the booklet that you have. You also have the bios in the booklet and the program, of course. So I think we have a great group, diverse group, international group. Some people come as far as from Seoul, from Kopri. We have people from Europe. So I think we really have a good starting point here for something that I expect will bring us further along in that process of trying to figure out how to connect with the action domain. So let's hand off to Brad for his introductory remarks.
Thank you, Peter. And wow, what a great group assembled here. That was awesome to hear everybody's affiliations and the work that you're doing, and to have everybody show up in New York in late July on such short notice for this, I think really speaks to our collective interest and energy and passion for this discussion. So I lead WWF US's ocean program, and the Arctic falls squarely within that program, but it also has an outsized impact on our climate program, which is why Lou Leonard is here as well, and obviously has an enormous number of science implications and science questions, and so we have our chief scientist here as well. So you can tell, and media people, you can tell WWF is really excited about this meeting and focused on what the possibilities are from this meeting. And I want to just give you a little bit of a reason of why we've sponsored it. So I've been working in conservation for 30 years and have watched this set of tools that we started with many years ago become more and more outdated in their application. And we have this progression that we call conservation 1.0, 2.0, 3.0 that we see in the conservation community of where we used to really think we could just set places aside and buffer them from human influence and human use, and it would be okay. We'd have enough of a living planet set aside to allow for the rest of the planet to function with human endeavor, and we'd be able to maintain some sort of a balance. That notion is long outdated, and we've recognized that obviously we've got to work with economic forces and all of the different drivers and pressures on natural resource systems and the uses, try to ameliorate the impacts, try to redesign so there are less impacts. That was sort of the whole conservation 2.0 model, which we're still in. We still use all these tools. But we're now really into uncharted territory in the conservation community. We are seeing most of what we care about being lost or going in the wrong direction. There are not a lot of trend lines that are going in a way that make us wake up really positive every day. I would love to wake up really positive every day, but it's hard to do when we see what's happening. And the Arctic is a really good example of that. It's out of sight, out of mind for most of the world's population. And even the title of this workshop, I think, is important because most people on the planet have no idea that the Arctic in a 2-degree C world is going to be much more of a significant change in the Arctic. And that's why we titled the workshop this way, because we've got to start communicating about the fact that 2 degrees C or even 1.5 degrees C global average, which is what all of the political entities are tilting towards right now, and they're not even lined up to achieve it, it's not going to be good enough, most likely. And we'll hear today from people much more expert than me about whether that's the case. But if that is the case, then we have to turn our attention to some new tools, and that's really the Conservation 3.0 piece. What are we going to do about it? I'm not a natural scientist, I'm a political scientist, which is sort of like being in a medical conference and saying I'm a doctor, but voodoo is what I practice. But I've been in science conferences my whole career, and I've listened to scientists, great scientists, describe the problems, as Peter said. We have described the problems very well. We are getting really good at documenting the problems. We're better and better at understanding them, even though that's very difficult in a place like the Arctic, maybe one of the most difficult places. But we've got to move beyond that to actually putting solutions on the table. And I know that there are boundaries in science that a lot of people are loath to cross about moving from description to action and description to prescription. And I'm not necessarily suggesting that's the outcome here, but I think one of the key messages we need to explore in these 2 days is whether there is science to be done about averting the worst of what we see coming. Not better understanding it so that some politician doesn't do anything about it, but science to avert. Not the actual actions to avert. We're going to talk about those and what we need to know, but really what are the key scientific questions and actions that we need to be putting into place now so that when we get to that point where countries or even independent entities on the world stage are taking actions, which is not hard to foresee, what will we know about the potential impacts and interactions and amplifications of those actions, and what will we be prepared to say and to do and to put out into the political arena as boundaries for that kind of work. So I really hope we can, from this meeting, communicate, first of all, the importance of the differential change in the Arctic and what that means, the 5-degree versus 2-degree, what that means to the globe. What are some of the major impacts that we are likely to see from that, which I know this has been done before, and then what do we think we might be able to start to put in place as the science foundation for plans to avert the worst of those impacts? Is it possible? How is it possible? What do we need to understand better? So that was a big motivation for us in sponsoring this great gathering of people to come together. We are focused, as Peter said, on the Arctic Science Ministerial as one touch point for people who might listen to some of this message and who are about to commit to collective science on the Arctic among a number of nations that will be gathered in that meeting. But that's only one point along the way that we're concerned about. Obviously, we really want to raise the profile of this question and to step out on it more and to daylight the fact that this is now a big part of the conservation question for the future. So again, thank you all for coming, and I really look forward to the next couple of days and to working with you beyond. And with that, I will turn it to Rafe Pomerantz.
I want to first thank especially Peter and Stephanie and Teresa and my colleague Brad and his colleague Margaret Williams, who isn't here, for working so hard to put this together. Hopefully we'll have a very useful and productive meeting, and it's good to be part of it. Peter, I want to say a word about the history here. As Peter mentioned, about 3.5 years ago, we met here at Columbia at a meeting entitled White Arctic, Blue Arctic, Exploring the Restoration of Sea Ice. Is that Bruno? No. It was a great meeting, 2 days, good discussion. But sometimes good ideas that are not forecasted come out of such meetings, and one of them was that we discussed an upcoming event in diplomatic circles known as the chairmanship of the Arctic Council. And it became clear that there was this convergence upon us that the United States was going to take over the chairmanship of the Arctic Council, that we had a Secretary of State who cared very deeply about climate change, John Kerry, and that the third, that looking through the lens of sea ice, the Arctic was, to put it mildly, changing very rapidly. The sea ice was in steep decline. In fact, we had that meeting, I think, on the heels of the record-setting year of 2012, which is still the record minimum, I believe. So out of that conversation, really, that was the start of this network that I chair, Arctic 21. And we began in an effort to support a decision by the State Department to make climate change in the Arctic a focus of the U.S. chairmanship, and that had been based on this discussion up here. And as a former Deputy Assistant Secretary of State, it is clear that when you have a chairmanship of a multilateral organization like the Arctic Council is a forcing mechanism. The U.S. had to decide, well, what are we exactly are we going to do with this opportunity? So many of my colleagues here in Arctic 21, I don't think we had a name then, we got together and engaged the State Department, and ultimately a decision, I think a great decision by the State Department to include climate change in the Arctic as a focus of the U.S. chairmanship was made. And that was a big leverage point because it gave a great deal of additional legitimacy, perhaps not in scientific circles, but everywhere else, to a focus on the question of what was happening to the Arctic. And in those conversations, we would discuss 5 indicators: sea ice, Northern Hemisphere spring snow cover, permafrost, Greenland, and the Arctic glaciers as indicators of what we call the unraveling of the Arctic. And so our task, as we saw it initially, was to communicate, in one word, the unraveling and all of its pieces to the media, to Congress, to NGOs, to anybody who was interested. And we formed this network. It's not a coalition. It doesn't have a single goal. Nobody's bound by anything. We get together, we meet, we come up with, we talk to government officials who are making critical decisions, whether they're from the White House or the State Department or whatever, and try to come up with strategies based on opportunity. So here we are, the Arctic Science Ministerial, which was actually born out of that idea came up, I think it was actually at a meeting that Jennifer Francis and I had at the State Department a couple of years ago with David Bolton. I remember in talking about why they should pay more attention. And I think the Science Ministerial was actually initially brainstormed over there, and but it has become something very different than I think that was imagined. So that's our job, and as we approach the second year of the U.S. chairmanship, we are trying to just we have 2 simple messages. One is to continue to communicate the unraveling, and we were delighted to support, although it wasn't exactly pleasant news, the work of Search. Brendan Kelly last week chaired a really good panel. I think Jennifer was on it. I don't know, I'm not sure we have anybody else on the State of the Arctic 2016, and it's a super slide deck on the key indicators, and that was a very, very valuable session, and I think those slides, certainly in those presentations, are a really great consolidation of the trends. That said, I think our second message may be more appropriate to this meeting. We're trying to do something new around at the policy end, and that is to frame the Arctic question, perhaps in a different way. I think both Brad and Peter hinted at this, or spoke to it pretty directly. This frame, we've come up with a question to establish the framework, which is, what is the Arctic we have to have? It's purposely a question, not an answer, but it's to generate a discussion about the limits to what is happening in the Arctic, and to bridge, it's a bridge between science and policy. The scientists can tell us what's happening, what the implications are, but it's really up to policymakers to come to grips and answer this question. That's the job of policymakers, and we're not. The Paris goals are global, they're not specific to the Arctic, they may or may not be ultimately appropriate to the Arctic. They're relevant, but they're not the only answer there. We have to be much more specific about particular parts of the climate system in order to respond fully to the situation. So our hope is that between now and the ministerial meeting in Fairbanks that will close the U.S. chairmanship and open the Finnish chairmanship, that we can establish this frame for policymakers based on the best science. What is the Arctic we have to have? So I think this meeting will be a great contribution. As has been said, the Arctic Science Ministerial is an opportunity to get this discussion underway, or at least use the moment to raise the profile of it, but there are many other opportunities on the way to bring this question into the appropriate forum. So thank you. Let's have a great meeting.
The way that this will work, as we noted, is 5 to 10 minute perspectives plus discussion. We set aside a lot of time for discussion to try to keep you on track. We have a handy dandy technology here, so there'll be a countdown indicator, and in talking with Vladimir, we decided we'll give you 8 minutes, and when you get to 10 minutes, it'll go into -2. When you get to -2, I'll stand up and I'll pull you off away from the microphone. So what we'll do with this first session, which is on a 5-degree Arctic with a question mark, we've got a lot of questions here today, is we'll be talking about trajectories towards a 5-degree Arctic, what are the implications of that, and what are some of the different aspects of it. Teresa, did you want to say something? Excuse me? Okay. Okay, great. So the first panel, the first part of this, will be looking at the physical and to some degree the chemical environment, and we'll start with, this will be the order, so just as a reminder, so Hayo Aiken will go first, and his background is in sea ice, as he indicated. Then Mikhail Karcher will talk, and he's talking about, his expertise is in the ice-ocean system. We'll then go to Doug Wallace, his background is in ocean changes and biogeochemistry. And then we'll end this, the first session with Charlie Vorosmarty, whose expertise is in water systems, and he's kind of a transition because he's also going to be talking a little bit about the social system side of this. So what we'd like to do is have each person come up and speak, and we'll load their presentation, and then you can go back and sit down so you can see the slides. I'll stay here so that I can, keep you on track in terms of the timing. For the discussion, we'll bring you all back up, and we'll have the general discussion with the people who had spoken, okay? So with that, let's start out with Hayo Aiken. And you can add to your introduction anything else that you'd like to say about your background that is relevant to this.
The only other thing I'd like to add to my background is that it's about 10 to 6 in the morning for me right now, so I think you should know that. But other than that, I appreciate the opportunity to speak to you. I was going to briefly cover what we can see at this point about sea ice in a 5-degree warmer Arctic. So here we are, and just as a reminder, I took the charge, or looked at the charge of the meeting program that Teresa sent out. So just as a quick reminder, looking at evolution of key components of the Arctic system, I'll briefly cover sea ice in that regard, but we were asked to consider economic and cultural values as well as management for integrity and resilience. I'll try to weave that into the conversation here as well. Relevant background documents, I particularly like Bob Newton's and others' paper that was part of the background materials. And I also refer you to analysis of sea ice hazards and services that Andy Mahoney and I completed last year that might be of interest here as well. So if we look at sort of starting from the present day and then projecting outward, just a quick reminder. So here are the patterns, trends in changes in ice concentration on a decadal scale in percent that we've seen for mean September ice concentration and mean March ice concentration. And the key message to take away from this here is that, as you'll notice, blue, we see the largest coherent areas of ice reduction or ice concentration reduction in the North American and Eastern Siberian Arctic, over in this area here, where we've seen in some areas statistically significant reductions by more than 15% ice concentration reduction per decade. And what's also important to point out, which I think is a pattern that we'll see continue into the future, is that if you look at the March for that same time period, so this is 1979 through 2014, we actually have an increase in ice concentration in the Bering Sea, but substantial reductions in the Sea of Okhotsk. And so along the margins in wintertime, we're experiencing these responses to changes in atmospheric circulation patterns, and maybe Michael is going to talk about that a bit more. We've got others in the audience who know a lot about it. But the implications of these are that, in particular, wintertime maximum ice extent is something that will remain to be highly variable, and that we have to think about carefully when we think about uses of ice or the relevance of ice in ecosystems. But of course, the key point is that the extent of perennial ice in the summer Arctic Ocean is projected to continue to decrease. Again, just a quick reminder: this is output from the biomass model that combines a number of different observations into an estimate of sea ice volume. So here's the decline in sea ice total volume over the course of winter between 79 and 2016 here, and here's the decline in summer volume. And what a lot of people do, and you know, you can argue about it one way or another, is to just look at the trend lines and see, well, where for example does this line here intersect with a volume of 0, and that gets you to somewhere in the 2030s, 2040s. Whether that's legitimate or not is another question. And in fact, if you look at climate model output, so here's a summary of the models that went into the fifth IPCC Assessment Report in a paper from Nguyen Wang and Jim Overland, and you can see that there's a significant range of output with respect to declines in the mean September ice extent as projected to evolve over the course of the century. And really what that tells us is that on the one hand there's uncertainty with respect to the actual date, but on the other hand what's reflected in here as well is the fact that defining an ice-free Arctic is something that, ice-free summer Arctic is something that we need to think about a bit more carefully. And if you look at the individual ensemble members for specific models, so here's an example from Nguyen's and Jim's paper that looks at, and I should point out to them, a nearly ice-free Arctic is less than 1 million square kilometers of summer sea ice. Now that 1 million square kilometers of summer sea ice, as you can see here, is confined to the high Canadian Greenland Arctic, can still serve a number of important functions and provide a number of important services. And so thinking carefully about how to manage various types of activities in these areas, of course, is an important aspect of policy or management of resources, and that's something I guess we'll have a chance to think about a bit more. So if we think about what type of services does sea ice provide, so this is now asking a bit more specifically what are the implications of some of this. As some of you in the room are aware, of course, very well, you know, we've got these 4 different categories of ecosystem services, or I prefer to think of them as environmental system services, ranging from the cultural services, use of the ice scape by indigenous peoples in the Arctic, up to the global scale regulating services. And if you look at these specifically, and you know, we don't have time to go into that in detail now, what we find is that actually a lot of these services aren't just increasing or decreasing in magnitude or impact, but that I guess what Rafe referred to as the unraveling, that you see that a lot of these are actually drifting off or trending off into different directions. And that in of itself is a significant challenge, I would argue, more so than the reduction in the number or the total volume of sea ice, is the question of how these different services, such as the role of sea ice as a hazard in marine coastal environments, but also at the same time as a platform that provides important provisioning services, is going to change in the future. And just as an example to illustrate what that means, here's an example of observations of the seasonal cycle of ice, starting with freeze-up, winter stable ice regime, breakup season, and open water season, obtained over about a decade's worth of observations in different coastal communities. These are observations here by Jill Levitt and Billy Adams, 2 Inupiaq environmental experts from Barrow. And what these observations and some of the data that we've been collecting show, and I think that's representative for other areas in the Arctic as well, is that the period of stable ice, the period where ice is predictable and stable from the perspective of local users. And this doesn't just include indigenous peoples, this would also include industry and others, is shrinking substantially. And if you look at this in more detail, we've actually looked at this in the Alaskan Arctic and defined the dates of ice breakup and ice freeze-up in terms of ice use. So this is a paper that's in press now, where we've tried to come up with a definition that's more oriented towards not just ice concentration, but actual ice use. You'll notice that the date of breakup is over the time period 79 to today is moving towards earlier dates, and these two curves here give you an idea of the range of different types of definitions of breakup, and at the same time freeze-up is being pushed later into the season. If you extrapolate these two lines here, you end up with a doubling of the open water season, time period in between these here, by 2030, and by 2100, all of the winter ice period is defined as open water with unstable ice conditions and a lack of a stable ice cover. Those actually, I think, are useful categories to think about in terms of sea ice. So the final point then, what does this all mean from the perspective of this meeting? I would argue that one of the key points with respect to sea ice uses, sea ice hazards, is that currently, and this now draws on this review and assessment that Andy and I did of overall sea ice hazards and services in the Arctic, we find that both activities, human activities as well as biological diversity, biological standing stock are largest along the margins of the Arctic Ocean. This is, of course, also where we're seeing the greatest exposure of different assets, whether it's communities or other types of infrastructure. But at the same time, this area here as well is a region where the sea ice hazards are largest. And actually, sea ice hazards are going to increase over the course of the next few decades, which leads me personally, at least, to conclude that one key aspect that we need to think about carefully is what do we see use and management of the use of the central and high Arctic to look like? And in particular, the Arctic Science Ministerial is an important point in that context, because of course a lot of the discussions then revolve around interpretation of the finer details of, say, marine scientific research in the context of the Convention of the Law of the Seas. And I'll leave you with that. Thanks.
Hayo spoke a lot about sea ice already. It's clear that in 5 to 10 minutes you cannot give a complete overview over all the trajectories of physical parameters, which was suggested somehow by the title of the session. So I will just give a few examples here. The sea ice thickness is one of the most worrisome parameters from a physical point of view. I think Hayo showed results from the biomass model, which assimilates data. Here we see a compilation, a very nice one, of Ron Lindsay and Axel Schweiger on all available observations in the Arctic, corrected for biases, and it clearly shows the very strong decline in Arctic yearly mean ice thickness in the central Arctic. Now a big question is, of course, when looking into future projections, how well do models represent especially coupled climate models represent the sea ice thickness distribution. And while even forced models, which are using observed atmosphere as a forcing, have problems in representing a good ice thickness distribution, this is even more the case for the coupled climate models. This is an example from Julian Struve showing 9 selected CMIP-5 models from 2004 to 2008. The number is skipped, unfortunately, and it just gives you an impression how very different the distribution in the models is in terms of ice thickness as compared to observations for this period here from ICESat. This is in particularly or may particularly be a problem when you start using single model results for interpreting regional areas, and it also may be a problem in terms of ice-ocean interaction, and ocean-atmosphere interaction, because ice thickness plays a very important role there. Similarly, with ice concentration, this is an example showing how the CMIP-5 models perform in a regional area here, the Barents Sea. It's the mean sea ice concentration for the period 1979 to 2005 from all CMIP-5 models shown in red here, the seasonal cycle, and in blue the observed seasonal cycle with an error margin or a variability margin, and it shows that basically the CMIP-5 models still, though they have been performing much better than the CMIP-3 models in the overall sea ice extent loss, have a problem with too much sea ice concentration, especially in winter. This is also the case, or still the case, when you look at a subset of the best 5 performers of sea ice concentration overall in the Arctic. You have this problem. Okay, CMIP is a coupled model intercomparison project. It is the set of coupled climate models which are used for the IPCC reports for the projections into the future. And those models not only look into the future, but they also cover the more recent decades, and there we have the chance to compare mean outcome from those models and those model ensembles with observed parameters to see how they perform in nowadays. And this is not the only one, but one important indicator for evaluating the quality of those models. Now coming to the ocean, looking further back, a large part of the water in the Arctic Ocean is coming from the south. It is advecting northward from the Atlantic, and here observations show that in the last decades we have a strong increase of the temperature of the warm water advecting northward into the Barents Sea and also into the Fram Strait, into the central Arctic. Here we see data compiled for the ICES report on ocean climate, the more southern areas at the overflows between Iceland and Scotland, in the lower red ellipse here, Paris-Shetland Channel, Norwegian Sea. All of those show between the 50s and 60s, and nowadays a strong increase of temperature. And the same holds for the water more northward in entering the Barents Sea and Fram Strait. This Fram Strait picture looks a bit crooked, therefore I put up another one. We see a clear indication of a rise. This figure, by the way, shows one of the problems we are having in getting an idea on the existing trajectory of all the data. This time series just goes back to the late 1990s, and we have a problem, of course, interpreting long-term changes based on observations which don't go back far enough. Now, what does this water do in the central Arctic? The Atlantic water, of course, has an impact on the ice cover in the Barents Sea when it enters at the surface, but we also have a large portion of this water diving below the cold and fresh halocline and circulating in the central Arctic. And here is an example for how this Atlantic water layer below the polar mixed layer has developed over the last decades, based on a work by Andrei Proshutinsky and co-workers for the Arctic Report Card, an example how the anomalies of the 2000s compared to the 1970s show an increase of warming in the Canadian basin, virtually almost everywhere, stronger even in the Eurasian basin. By the way, the 70s is just one of the very few periods in the past where we have a rather dense coverage with observations due to Russian activities in that area, in that period. It's much worse in the 80s and only beefs up in the IPY period. Coming to freshwater, another parameter which is of high interest in the central Arctic Ocean. Many people may be aware, dealing with the Arctic Ocean oceanography, that we had a strong rise, a strong increase of the liquid freshwater content in the last decades. here shown as green stars, the development from 1992 to 2012, a work from Benjamin Rabe in our group at AVI, compared to model observations is a good one. Model results of our NeoSim model showing this increase, and it also shows an example of analysis we are doing to try to understand what is actually driving the waxing and waning of freshwater content in the Arctic Ocean. What are the drivers for the freshwater storage and release? What are the mechanisms involved? And we find the Beaufort High or cyclonicity of the airfield, the most important parameter for driving the variability on an interannual time scale. Since we cannot go further back with observations than the early 1990s, we have to rely on models to go further back and investigate the mechanisms there. And one of those examples is from our NeoSim model here, showing the period from the 50s to the 2000s. This is the same picture as I just showed before, showing this extraction. And we see that we also have large variability on the decadal time scale, and in the model we also find that this decadal scale variability, as was suggested by Andrei Proshetinsky, in fact is driven by variability in the Beaufort High. Now the question is, how do one important question with respect to freshwater content of the Arctic Ocean is going beyond the Arctic proper. It's the question of how much does it affect the exports of fresh water, which then can impact the overturning further south. And for this, it is important to understand whether the coupled climate models are doing a decent job in representing the storage and release mechanisms of freshwater and the distribution of freshwater in the Arctic. And here is an example from a paper where we put together all present knowledge on freshwater variability in the Arctic, also looking at some examples of the CMIP models, two CMIP 3 models and two CMIP 5 models shown here, in their freshwater change at the end of the century as compared to the beginning of this century, showing very different distribution patterns, bipolar or with changes in both directions. In some models, like here with the GFDL model, in others the entire Arctic is affected. And as you may imagine, the distribution of this freshwater and how the mechanisms are represented has an effect on where this freshwater is going to leave the Arctic, and this is important for the impact on the overturning. To give you an idea where the models are similar, these same models as time series shown how they show the development of the freshwater content to the end of the century. Most of these models actually show a strong increase of freshwater content in liquid form in the Arctic, and it will be important in future to try to investigate whether the storage and release mechanisms for this are well captured by these models, and whether this plays a role in this more or less steady increase. To summarize, for the ocean, the trajectories requested, we do have a warming trend of northbound Atlantic water over several decades now entering the Arctic, which by this effect is warmed strongly below the halicline since the 80s and 70s. There is a discussion on the role of additional ice melt in certain areas, depending on the stratification. I didn't go into that. We have a strong increase of liquid freshwater in the last decades. The role of the Beaufort High, the surface stress curl, is an important one for storage and release, and it's the question how this is reflected in CMIP models, which project a strong increase of freshwater content for the coming decade, for the coming century. It's unclear how well these are captured, and how you already discussed a lot of the ice issues. being asked what to do, I strictly look from the perspective of physical sciences. Now, later on in the discussion, we can certainly go into what it means for other areas of research or society. That's rather mundane, but in it...
But effective, yeah.
Yeah, but effective. We can probably pick up this discussion later on. Okay, thank you, and sorry for being late.
No, it's okay.
So MEOPAR, as Peter told you what it stands for Marine Environmental Observation, Prediction and Response. It's a network of centers of excellence. Some of you, maybe many of you, might have heard of a related program in Canada called ArcticNet. And ArcticNet is also a network. It's coming to the end of its, I think, 15-year life frame in the next couple of years. MEOPAR is a similar funding body in Canada, networks people. I'll say a little bit about it. Its acronym evolved from a committee, not surprisingly, as you could tell, but we're transitioning it from being an acronym to being a verb. We are talking now, we will MEOPAR, to MEOPAR. Because what's observation, it's not enough on its own. Prediction without observation doesn't make much sense. And response, observation and prediction without figuring out what to do about the predictions doesn't make much sense either. So what should you do? You should MEOPAR. I've convinced you, I can see. Okay, I'm going to talk a bit about some Arctic changes, trying to pick up on some things which maybe haven't been identified yet, although some I think already have. The point is, the title's not very interesting, but just if you put only 3 letters in the word change, you get challenge, right? And so challenges are very closely related to changes, and nowhere more so than in the Arctic, as I think we all realize. So MEOPAR is a national, just a quick advertisement for us. MEOPAR is a network which supports interdisciplinary research across Canada, but also internationally. We do a lot of work on providing training and work experience for our students and postdocs, and we are very focused on mobilizing knowledge to end users. And in the first funding cycle, we spent a lot of money on research. These are Canadian dollars, however, so just bear that in mind. And we presently have research projects going on in 24 universities across Canada, including in Saskatchewan, and of course in Calgary, of course. So we're truly nationwide, and we're coast to coast to coast in Canada. So the Arctic is one part of our research, but not by any means the only part. However, in our second funding cycle, which we're just hoping to enter into at the beginning of next year, we're definitely going to have a stronger focus on the Arctic than we did before. And we're going to be focusing on 2 major drivers of change, one being environmental change, but the other being changing human activities, changing uses of the marine environment, and their impacts on coastal communities, on the marine ecosystem and the living resources, including the marine industries that depend on the marine ecosystem, and on the other marine industries, including, of course, shipping, but also tourism, offshore industries, etc. So the Arctic Ocean, as we've seen, it's by no means a closed system. We can focus in on the Arctic, but as Mikael just pointed out, it's heavily influenced by its exchanges at the boundaries. And those exchanges include inflow and outflow through Fram Strait and the Barents Sea, including of relatively warm waters, but of course an inter-ocean transport through Bering Strait. And certainly the Arctic, in one, if you like, ecosystem service that the Arctic provides is connecting the Pacific and the Atlantic Oceans. So one aspect which I think is especially important, though, is that the impacts of Arctic change in terms of teleconnections to other regions of the ocean, through the ocean, strongly, of course, impact first and foremost the Atlantic, through transports through the Canadian Arctic archipelago and also along the eastern coast of Greenland. A big challenge for all of Arctic research, again, as pointed out earlier, is data. We have limited data sets which extend back more than the 1990s. This is a plot of where it's possible in Canada to extract long-term temperature changes on the Canadian landmass, and you can see the sparsity of locations, even on land, where we have even enough data to identify temperature changes since 1950. And for other properties, this is much worse, and we have almost no such sites, or have no such sites in the Canadian Arctic Ocean regions. So So I'm just going to point out a couple of areas where we can see things from coastal stations, Alert, Pond Inlet and Clyde River, these rough locations here. And you can start to see that these changes that are heavily dominated by recent warming in these three locations. And in a few locations, including Alert and Clyde River, we have enough data to identify changes in wind speed and wind stress and so on, but again, restricted to coastal sites. So this presentation is focusing very much on the Canadian Arctic, of course. And the data are in these from a review published by Nadja Steiner et al. A few years ago. If we start to think about stratification, and again touched on by Mikhail here, we have far fewer data to identify stratification. The top plot is one of, I think, the only long-term time series of salinity from the southern Beaufort Sea in the Canadian Arctic. Extends back to 1985 for temperature. But for salinity, which of course dominates stratification, the data only started being collected in 1999. So we have only half of the time series. So no trend in apparent temperature from this particular region, but we have no real information at all on salinity variations. And this is for bottom water on the shelf, the depth of about 50 meters. Because of the problems of ice cover, seasonal ice cover, it's almost has been very difficult to maintain long-term moored time series covering the whole annual cycle in the surface layer, in the mixed layer. So we have almost no information at all of long-term near-surface changes in salinity and therefore of stratification. Freshwater storage has been it was just discussed by Mikhail. If we think about the future, the recent past and the biogeochemical future, here are some model projections from these are multi-model differences for 50-year projections into the future compared to the time period of the late 90s, early 2000 periods. In the top, nitrate, surface nitrate, focused in the Canada basin of the Arctic. In the bottom, pH. So two fairly classical biogeochemical parameters. Not surprisingly, the projections for nitrate show a depletion of surface nitrate associated with removal of summer ice cover, increased light, and possibly, although I don't think this is fully understood, the balance between that and increased stratification. And on the lower panel, a significant decrease in pH or an increase in ocean acidification associated with increased CO2, partly due to reduced ice cover, increasing air-sea gas exchange, allowing CO2 to equilibrate more rapidly with the surface layer of the ocean, but especially with freshwater changes and reduced buffering of the seawater, which again depends on the source of freshwater, whether that's from river input or sea ice meltwater, has a very different impact on the chemical buffering of the Arctic surface layer. So we're expecting lower nutrient levels in summer especially, and lower pH. In terms of, again, the same multi-model comparison, you start to look here in a bit of detail of, in the top panel, salinity changes, again on a 50-year projection here, and on the bottom level, the saturation state for aragonite, one of the key parameters affected by ocean acidification. And on the top panel, the major point is to see just what Mikhail said, a kind of an increase in the freshwater inventory, a decrease in the salinity of the upper ocean, extending down to about 200 meters through the halocline, but significant model-to-model differences, including one fairly extreme case where the surface layer turns into a lake, in effect, zero salinity in the mixed layer, which it would be interesting. And on the lower panel, the changes in saturation state for aragonite, again showing decreased saturation such that the aragonite saturation goes significantly below 1 in the next 50 years throughout the Canada Basin. You can see the multi-model averages there, that time progression on the furthest right panel. But on the first panel, we see comparison with observations. The black triangles on the first panel are very, very limited observations from 1 year, 2005. And you can see the issue we have in terms of validating these model representations of biogeochemistry. We still have, even in summer, a relatively few data, and so that we can't really, I don't think, adequately tease out the present-day validation, let alone how we're going to go into the future. At least this is a very big challenge. So last point is downstream effects. Just want to raise them, is that especially the biogeochemistry in the Arctic has an impact, I firmly believe, on pretty much the entire east coast, eastern seaboard, certainly of North America. As a result of that outflow of fresh water along the coastal boundary current, which extends pretty much as far as Cape Hatteras, changes to nutrient cycling, increased productivity in the Arctic could potentially lead to nutrient trapping in the Arctic and decreased nutrient export to the Atlantic. And this is something I think we have to really start thinking about. There is a supply of nutrients through Bering Strait, through the Arctic, into the Atlantic. Is it possible that with decreased ice cover and potentially increased stratification in the Arctic, that transport's reduced, impacting the fisheries along the whole eastern seaboard? And I'll leave you with a few other key points which I think we might want to address, but especially, and I've not had time to mention it, impacts on carbon cycling, especially with increased inputs of DOC to the Arctic. What will associated with permafrost melting? What will happen to that DOC in a completely changed Arctic? Thank you.
So now we'll be transitioning to Charlie. Does anybody have a question for Doug as he's going back and we're putting up the other set of slides? Yeah, go ahead.
Yeah, estimates about the increase in the total decrease in the
Well, we know the nutrient transport into the Arctic through Bering Strait. We know it reasonably well, and the real question is what happens in a more productive Arctic to those nutrients. Do they get sequestered into the deeper layers of the Arctic or not? And I don't think at the moment, I'm not aware of an estimate of how significant that could be, but we saw that the surface nitrate level in those model projections was about 3 micromolar lower, which implies that the outflowing fresh water from the Arctic will be lower in nitrate than it presently is.
I like change-up pitches in baseball, and I'm going to give you guys a change-up pitch, as it were. As important as I think it is to be articulating these changes in different domains, different disciplinary domains, I think one of the main challenges, especially as we reach out to policymakers, is to really understand the systemic aspects of these questions. How does it all fit together? And I thought I could use my 8 minutes here, or 10 minutes, to describe a couple of initiatives that are in more or less nascent phase that certainly I hope members of this gathering could participate in. And the first such one is something called the Arctic Futures Initiative, which is headquartered at the International Institute for Applied Systems Analysis. It's in Luxembourg, Austria. And as you might imagine by the name of the institute, it's trying to forward systemic perspectives, in particular looking at the Arctic. It has actually a series of different futures initiatives, but the Arctic is one of the premier ones that has now taken hold. I'm part of a planning team of about a dozen people from a variety of different backgrounds, both biogeophysical scientists as well as policy experts, people who are engaged, in fact, at the Arctic Council level, with reaching out directly to policymakers in the realm of this systems-based science. IASA, we believe, is in a very, very important position to, in some sense, be a steward of systemic questions regarding the Arctic directly relevant to policy, and from the standpoint of making 3 arguments here. First of all, given the history of IASA and its systems level thinking, it's trying to promote an understanding of what we might view as individually interesting facets of the problem, but really trying to couple these together to look at the system both biogeophysically and also in terms of its social and decision-making dimensions. So we're trying to integrate these perspectives across the research, the policy, the business, indigenous and local communities. And YASA, in the spirit of what YASA has done for nearly, 50 years now, or 40 years at least, founded in the early 1970s, a product of some thinking during the Cold War between, Gromyko and the Johnson administration. It opened, I believe, in 1972, and it brought together East Bloc and Western scientists in what amounted to interesting Cold War think tank and, in my view, a den of spies. But nonetheless, it was always a fair broker in terms of identifying major environmental challenges and trying to be a fair broker to come up with solutions. This kind of, I would say, sensibility about these kinds of questions is being brought to bear on the Arctic as well. We are collaborating directly with very specific communities. The Arctic Council has a direct line of communication to the Arctic Futures Initiative. We're working with the senior Arctic officials, the variety of working groups in the Arctic Councils. We're assembling indigenous peoples and groups that represent indigenous peoples and various affiliated projects that are sanctioned by the Arctic Council. We have made efforts to bring in economic interest in the business community through, in particular, the Arctic Economic Council. IASC is part of the planning, WWF, and specific programs and projects that have made a variety of additional insights and contributions to our planning. The primary research goal is to improve the understanding of Arctic system dynamics, okay, and also understand how change would institute human actions, and human actions will potentially produce feedbacks within the system. So one of the key aspects of this is to articulate the role of the Arctic as a region. It certainly is not bounded to itself. It's connected to the Earth system. That's one of the important systemic components we're looking at. We're attempting to work with policymakers, decision makers directly to co-design scenarios of future trajectories of development. We recognize the arena is going to be developing, potentially for better, potentially for worse, but what we'd like to do is we'd like to, in some sense, shepherd the dialogue through both a scientific process and a policymaking process. The idea is to assess very specific impacts of these human decisions as they create potential feedbacks in the systems and potential responses by the decision makers thereafter. And I guess schematically here, the ideas focusing on the left is the formulation of these policy alternatives. And we're co-designing this again with researchers and stakeholders. And to place storylines into a quantitative framework that would allow us to put these into systems analysis models. And these might not be complex Earth system models. They might actually be lower dimensional algorithms that would allow rapid interaction with policymakers so we could test some ideas out relatively quickly. So the idea is to articulate impacts of particular policies on the social and Earth systems subcomponents of the Arctic, and then in turn, what impacts do those feedbacks potentially apply to new decisions that are going to be made as we move through time. We also are trying to stimulate analyses of what types of observatory networks, and we just heard in the last talk the problems with that. What kind of observatories would you need to pick up these systemic changes? So an anticipated legacy of the effort is to create new knowledge, is to create practical options for the decision-making bodies, and to create as it were, a lasting framework for this kind of dialogue, bringing individual disciplinary perspectives into a more systemic realm. And in addition, we wish to be training a new generations of system analysts who can begin to look at the system both from a scientific standpoint and convey that out to the decision makers. Here's a timeline of the effort. We're ending basically our planning phase. We're moving now into a development phase and then ultimately launching the effort in a real way in the 2017 timeframe. There's an information, I think it's at the end of my
slide set where you can take a look at that website which will describe this in more detail. Okay, another effort I'd like to talk to you about comes actually from the world of NSF and ARCS, where I'm part of a team that's creating a workshop series on synthesis. I've swapped the slides, I'm sorry about that, but this was from the last portion of the talk. So the title of our NSF ARCS workshop series is Community Workshops for Synthesis Studies of the Pan-Arctic Earth System. Here we have about 10 people planning this, and Jennifer's one of the premier planners, along with myself and some others listed here. The goals of this set of gatherings is to execute some prototype systems level studies on some key Arctic system change issues, and pose these as, I guess we would call them, challenge questions. And the questions revolve around the biogeophysical sources and mechanisms which give rise to extreme events in the Arctic. We hear a lot about this in terms of the general discussion of climate change, which has actually pervaded, I think, some of the public mindset about climate change, that it's creating more extreme conditions. We'd like to focus on this phenomenon in the Arctic, and also begin to develop, as I mentioned, the notion of the value of bringing together disciplinary perspectives into a systemic whole. We're going to be looking at so-called integrated currencies. Some of you here were involved with the freshwater integration study from about a decade ago, where we looked only at water. Now we're looking as well as at energy, carbon, and nutrients as potential mechanisms which regulate the systemic behavior of Arctic to change. And along the way, we hope to produce 2 peer-reviewed publications. The second goal is to produce a strategic white paper that would be delivered to the National Science Foundation on opportunities for doing new systems level science, new research approaches, technical and programmatic support, leading potentially to this notion of producing an Arctic synthesis collaboratory around which the community could rally to tackle these kinds of questions. The timing of the events, first one would be on the extremes. That'll be the second week of November 2016. Workshop number 2 on these currencies, these different elemental cycles, would be the first week of February 2017. Then there'll be a writing workshop in April to boil off the key salient features that came out of that set of discussions, the workshop 1 and workshop 2, and produce that document. Questions, comments, and discussion to follow.
So we heard a picture of a future Arctic in summer that has, less than 1 million square kilometers of ice. It's got probably lower nutrients in summer, and related to that obviously is an increase in the freshwater inventory and a decrease in the salinity, and that there will be multiple storylines that will be evolving over the future, and Charlie talked about some ways to explore those. So let's just open this up. First of all, maybe anybody who spoke, if you wanted to comment on the other presentations or anything else that you had wanted to add. No? Okay, great. So let's go out. So Peter, go ahead. And remember to use the microphones.
So if we are looking at these projections, I try to figure out which emission scenarios were actually used, because especially in the context of this workshop where we are looking at a 2 degree, which would be RCP 2.6 or 421 ppm equivalent CO2 in the atmosphere, it is really important to make clear what are we looking at in terms of the emission world. Is there any? I mean, I assume that some of them were the 4.5 or higher emission scenario, but could any of you comment on which ones you actually picked and for which reason?
Well, I picked the one that was in the paper by Nadja Steiner, which was I think it was 8.5. It was very high, but that was a Canadian pessimistic view of the world.
Yeah, just to add to that, I think that's an important point. And I think there's a paper that looks at how the CS cover evolves for the different scenarios that's in press that actually would be interesting to look at in more detail, so you don't get confused about what the actual baseline is that we're talking about here.
And maybe we can, if you can give us the hint to where we can, if it is in press, sometimes it's actually pre-published on websites. We could distribute it so that we have that as a background for our discussion, especially tomorrow, because there we really have to focus in when we say a 2 degree, 1.5 to 2 degree, global, what would the Arctic do, so that would really be important to have.
Thank you.
Yeah, over there. You're right in the bright light that was there, so thanks for waving.
Yes, sorry, but I think this is something that I actually missed. We have specialists sitting here and then very integrated looking people, and there might be a gap in between, and I sometimes have this global view. For the Arctic, it's kind of simple in a sense with respect to the temperature. It sounds awful, that's because I have this perspective, but independent of the emission scenario, the next 25 years are fixed, not just in the Arctic, but globally. I have the slide here. I'm going to show it in the afternoon, but it's long. It's not a deep thing. It's already in the IPCC report. But for the next 25 years, we will reach something around 2 degrees globally. Could be 1.5, could be 2. Something that this is within the uncertainty range of the models. But the RCP 8.5 and 2.6 don't distinguish really within the uncertainty of the models, these two scenarios until 2040, which is incidentally the time when we reach the 2 degrees. So any projections are the same until 2040, and it's the moment when the Arctic gets ice-free in summer. Sorry, my very coarse view on this. For any I have seen that how you showed this, that this is much more complicated, and these sea ice will be still there in some places, independent, even for high scenarios and so on and so forth. But from a bird's eye view, we'll get in 2040 we get an Arctic that is in summer almost ice-free, and we'll have 2 degrees or 1.5, 2 degrees, something like this. And then the further evolution will depend on what we do in the next 25 years with respect to emissions. I thought this was important for the entire discussion because 25 years is what we are interested in a lot of circumstances, politically, economically, and so on.
Yeah, I think that's an important point. People have talked about that generally, but they haven't applied it so much to the Arctic scenario. And so I think that could be part of our takeaway points that we want to drive home, from this conference. Yeah, go ahead.
Yeah.
And then over here.
I would like to add something. This is only valid to the point that we estimate internal or say natural variability correctly. Okay, so in the case that we underestimate the level of internal variability, and I will get to this in the afternoon, then the ice-free Arctic around the middle of the century or so may actually not happen. So that's just a caveat I want to add here, because the future evolution is given by both, by the anthropogenic trend plus the internal or the natural variability that rides on top of that. And that can be quite strong. It has been quite strong in the past, and who knows how it will evolve in the future.
But how is this going to save us from ice-free Arctic in the middle of the century? I don't see that. I mean, it could be temporarily, that you keep a little bit of ice for a while, but how is this saving us for long? I don't understand that.
I'm not saying for long. Right, so I think we all agree if we continue on this path, independently, whether it's 4.5 or 8.5 or so, say by the end of the century or maybe even earlier, we will have an ice-free Arctic. Okay, all I'm saying is that we need to apply some caution here if we specify, it too detailed. If we just say, 2040 is the time, it's a range of possibilities. It can be also 2070.
Okay, so, Mikhail first on the panel, then Peter, then Radley, then Brendan, and then Scott.
Yeah, just adding up on that, I agree with Mojib. This is one of the reasons why in the Access project, where we have been using data from the physical sciences for the social and socioeconomic domain as an input, and where we have been looking at the timescale up to 2040, why we have been very careful in conversing the message that everyone will have to live with a large range of uncertainty until this area, even though the previous commenter was correct, Andreas, who said that the emission scenarios don't differ a lot, basically, until 2040. But this overlap of the long-term trend and the internal variability leaves a large uncertainty, and everybody who's using those data needs to be aware of that. So people using those climate projections need to rather investigate the sensitivity of their specific system than looking for a very specific situation which will occur. It's about the sensitivity, I think, of all the systems, socioeconomic systems and so on.
Peter?
So we are actually at the time where real investments are being made in shipping routes and things like that. I do believe, talking to those who are involved in that, that they have a good sense that there is variability and there is an uncertainty in the exact timing. And they are building that into their sort of investment models, into the kind of infrastructure you need to keep the sea route, the northern sea route, ice-free. The question I have for those who are modeling the system, because of course we cannot observe into the future, is to which extent do we actually know the memory of the system with respect to that variability? So can you really have a 1 year sort of anomaly that is huge and then it's gone the next year? I mean, or do you have periods of certain time intervals, let's say, a few years, or is it even a decade of such an anomaly, or do we not know that? Because if we are sort of looking at how to use that, or if people are starting to use the Arctic for commercial interests, that is a very important factor, but also, the indigenous use, etc. You want to have a sense of how this variability looks in a frequency space.
Well, if you look at the sea ice extent time series, which is available from satellites, you can see that you have these very strong changes from 1 year to the other. So this can happen, and I think that due to the reduced ice thickness overall, the sea ice, as many others have stated, is very vulnerable and very sensitive to changes in the atmospheric circulation. Or in terms of northward heat transport events and so on. So I think we will have to live with these very strong changes from year to year, superimposed on the long-term trend. And then an additional difficulty will be decadal variability, which Mojib referred to, which may add to the problem. But there is certainly some kind of memory in something like the sea ice thickness, more than in the sea ice extent, for sure. And there may even be some memory in the ocean heat storage in the mixed layer. But this doesn't prevent, or has not prevented in the past, the sea ice extent to show high variability. And then in addition to that, if you're looking into real practical considerations like shipping routes, we have clear indications that in the past, and the same holds for the prediction models, if you look into the ice cover along the shipping routes, that even in a situation where you have a very reduced ice cover, which in principle would be ice-free for shipping, you still can have blocking in specific key locations like straits and so forth, which still makes the use of icebreakers or ways around this necessary. So I think that's that's the message we have to convey to those people who are using the data.
Yeah, I think the issue of variability, go ahead, did you want to respond?
Yeah, just to add to that, I mean, people have looked at variability and autocorrelation on the pan-Arctic scale, and so the conclusion so far is there is no autocorrelation on those time scales. But the question is whether at the regional level, the variability of synoptic conditions, weather, you know, and other factors that drive ice extent in, say, the North American Arctic or along parts of the eastern Siberian Sea, has some predictive skill from year to year, because that's where, you know, if you have buildup of very thick ice where you know that this is going to circulate into certain areas, that can provide for some predictive skill on timescales beyond a single year at the regional level. But even that, I haven't seen any clear sort of scientific analysis in quantitative fashion of that, but heuristically, you know, it gives you a sense of what's possible. But the one point though to make is, and I think that's an important one, is that what I'm sensing here as well is that we're thinking too much in terms of snapshots or single time slices of the distribution of ice. I mean, from an operator perspective, they don't care about what the September mean extent is, or even the minimum. I mean, they're operating in a time period, and what you're seeing is, and I think you were alluding to that, is that a lot of people are starting to recognize that the transformation of the ice cover in the interior Arctic allows you to plan around shipping or other uses of the ice over much longer time periods of a year, and for that you don't need to know about anomalies in ice extent or any of these other things that we've been looking at, but you need to look at what are the more specific qualities of the ice, what's the probability of encountering convergent ice conditions where you can trap vessels and so forth. And the conclusion that we've drawn from this analysis of hazards is that the lowest risk from a shipping perspective actually is encountered in the central Arctic. And so my argument would be that we need to look very carefully at what type of management regimes are in place for those areas that haven't been important in the past, because that's where you can make both a big difference right now, because that's where business interests are lying. You know, Korea has built a vessel that's designed specifically to go outside of the Russian EEZ, and a lot of the discussions that so far have focused on marginal seas then become very, you know, are transformed in substance.
Okay. Bradley? Microphone. Oh, you have it. Okay.
So maybe taking sort of the other angle on that point, from a speculative perspective, if we're unlucky, if natural variability gives us an ice-free summer soon, very soon, does that have implications on the trajectory of future variability? What do we know about what that implies for future, in the next year's winter sea ice extent? If we have a bad luck from a variability perspective, it puts us, you know, very low, does that change the whole outcome? That's obviously very speculative. As the ice gets thinner, as the ice gets more corrupt in some sense, does that in itself reduce the predictability of our models? So is there a way we can, you know, build in some of that thinking without something that's to some extent driven by an initial variability that could completely change not just the social trajectory of how we might respond, but also our sort of understanding of you know, how rapidly things could change thereafter.
Right. Brendan?
So Hayo's presentation talked about a nearly ice-free Arctic, and he talked about how the ice that does remain in late summer will be important in terms of services it provides. Obviously, it's important for ecosystems, important for people, but throughout this discussion, we're using an ice-free Arctic over and over again. I strongly urge us to stop doing it. I really do. I spent a lot of time explaining to very, very smart policymakers, well, actually, we don't really mean an ice-free Arctic. We mean a much reduced ice in the summertime, and you have to talk about the seasonality of the ice and what we mean when we use this very loose term, ice-free. We're not doing ourselves any good. You've sort of stated we want to keep our eye on the solution as part of our deliberations here. We're not helping any when we misspeak like that.
Yeah, we should, this came up yesterday when I was at the White House too, that we need to be keep reminding people that there will be ice in the wintertime, and then in the summertime, it will be nearly ice-free or much reduced. So a quick response? Okay.
Just really quickly on that debate, and there'll be people here who know this, but there's the policymakers, but there's also the people who make business decisions, and has the implications of 1 or 2 years of very, very low ice cover in the central Arctic Ocean on the industry? Has that been factored in precisely the way that was just mentioned with the investments in building vessels that, whether the science is solid or not, where people just take a chance? Has that been studied adequately?
Right, so that could be added to our research perspective. So let's just take Scott, and then we need to take a break, sorry. We will be continuing to talk about the Arctic afterward, the break, so go ahead, Scott.
Okay, this might be something to pick up later as well, but just to get us thinking. Again, with an eye towards bridging science and policy, and speaking maybe specifically to what Michael was talking about with regard to intermodal differences, I'm wondering how constructive or useful is it to continue to have a discussion about intermodal uncertainties in a policy context, because I feel like sometimes when we use the term uncertainty around policymakers, it kind of it implies a certain meaning that perhaps we're not sure about what the future of the Arctic will be, when in fact there actually is a more robust scientific meaning for that term, and to what extent that actually furthers the conversation.
So I think tomorrow in the morning we'll be talking about governance and issues in communication, as well as adaptation and mitigation and strategies, and so I think we can definitely take up the communication side of it.